So we're supposed to find the volume of this box over here. Well, we know volume of a box is length times width times height. Our length is x, our width is x, and our height is h. So it's going to be x times x times, sorry about that, x times h. And we know that x times x we could write as x squared. So it wanted our volume in terms of h and x, which we have, because it means it wants your volume equaling something with x's and h's in it. Well, you look down below here, now it says find the volume of your box only with x's. In other words, they don't want h. So we got to figure out what does h represent so that we can go ahead and plug it in. Well, we have not used the whole idea of the 24 feet for our perimeter. We know our perimeter is 24 feet. Perimeter is distance around your whole shape here. Well, this is a 4x. This is an h. Well, coming back across here would be another 4x. And then you'd have another h coming down this side. So if we go ahead and simplify this, we would get this here. Well, trying to solve it for h, because we got to replace h with something, we could subtract an 8x on both sides. Now we could divide by 2, and we get h to be this. So all we're going to do is take this value right here of our negative 4x plus 12 and plug it in for h. So instead of having h, we have our negative 4x plus 12. We could leave it like that because we technically have our volume equaling something only with x's, but typically you're going to go ahead and distribute through and get rid of the parentheses. Well, down below here it says we need to go ahead and find our domain. Well, we have our domain here. Domain would be the types of x's we can use. Well, also thinking of our box here, we know that our x and our h can't be negative because we cannot have a negative length. Also, if x was 0, it wouldn't be a box. If h was 0, it would not be a box. So our x has to be greater than 0. And our h, which is this here, has to be greater than 0. Because we can't have negative lengths or lengths equal to 0. So if we just go ahead and take this h greater than 0, which is the negative 4x plus 12 greater than 0, and solve that for x, we can subtract our 12 from both sides, divide by our negative 4. Remember, when you divide by negative, to switch your inequality sign. So we know our domain has to be greater than 0, but less than 3. In other words, we could say it's between 0 and 3. Then it wants you to go ahead and graph this volume function right here in blue, which I'm assuming you can do, but remember to graph it on an appropriate window. So you want to remember what x is representing, and we know our domain for x, 0 to 3, and we know that our volume can't be negative, so when you're thinking of your window for your graph, your x-min would be 0, x-max would be 3. Your y-min would be 0, your x-max, y-max, that should be, sorry about that. This, you're going to just have to play around until you actually get the whole curve to show up. My guess is it's going to be fairly large, so just play around with it until you get your graph to show up, and then you should be able to go ahead and find your maximum, which would be your top point. So here is an appropriate graph, and we need to go ahead and find our maximum. You could just hit trace and move your cursor along to try to estimate the top. The easiest way, it looks like it's about 2, so the easiest way to do it is to go second trace, and we're going to select number 4, which is maximum. It says left bound. We got to be to the left of where our maximum is. Yeah, we're to the left of where it is because our maximum's over here to the right, so we'll hit enter. Now we got to be to the right of our maximum. Well, you could move your cursor over, or you could type in the number that's to the right, and I knew it was around 2, so I'll type in 2.5 just to be to the right, and I'm not going to guess. I'm going to hit enter. And hey, the X that gives me my maximum is 2. My maximum volume would be 16. So my maximum volume would be 16 with appropriate units. We're dealing with feet, so my volume would be 16 feet cubed.